and welcome to today's episode of Rawkode Live. I am Rawkode, your host, also known as David Mackay, but all the good handles were taken, unfortunately. I want to thank my employer, Equinix Metal. They afford me time to invest into producing these shows and getting, experts from around the world to come and introduce us to all of their fantastic software. So thank you, Equinix Metal. If you want to try out Equinix Metal, you can use the code Rawkode Live. This will get you $50 of compute time. You can splurge that in a few hours with 400 gig of RAM and 96 cores or more, or you can be a little bit more conservative and have that run for up to 10 hours or a couple of days, depending on the machine and hardware that you use. So check that out. It's good to have a fun. We also have a Discord channel if you want to continue this conversation or you're not watching this live and have questions. You can find that at rawkodelive.com/chat. Now today, we're going to be taking a look at Linkerd, a cloud-native service mesh by Buoyant. And we're very lucky that today we have Thomas Rampelberg from Buoyant himself, who's going to guide us through our Linkerd journey. Hello, Thomas. How are you?
I am doing fantastic. So excited to be here.
Awesome. Do you want to just tell us a little bit about what you do at Buoyant?
Yeah, you bet. I'm a software engineer at Buoyant. Buoyant's kind of the creators of the service mesh. Linkerd version 1 was the first original one. We went through a pretty big rewrite based off of everything we learned from version 1. And we've got Linkerd 2, which is the product that we're going to be talking about today. And I do software engineering and help maintain that.
Awesome. Now, service mesh might be a new term to some of the people that we have watching. So can we maybe just break that down a little bit and say, what are some of the responsibilities for a service mesh?
Yeah, you bet. So let's talk a little bit about how it all got started. Back in the day at Twitter, they kind of started out as a monolith, giant Ruby on Rails application. And as the organization scaled and folks got more and more frustrated with the fail whale, they needed to go split out into microservices. And once you start splitting out into microservices, there's these concerns that pretty much everybody needs to go and implement. You need to have a common observability stack. So you need to have metrics that are the same across all the microservices, whatever language they're written in. You need to have reliability concerns, retries, timeouts, routing decisions, smart load balancing. And you need to have security, so mTLS. Those three things, at Twitter, they created a library called Finagle to implement that because they were writing all of their microservices in a single language, Scala. But most organizations who do microservices, one of the big wins there is that you get to write in whatever language you want. And so Linkerd, the first service mesh, was kind of created as a way to go and pull all of the, we're going to call them operational concerns like security and reliability and metrics out of developers' apps and into a proxy that the operators can go and deploy. And so Linkerd 2 basically does that. It is a sidecar proxy that gets deployed alongside your application, and that goes and provides all of those benefits. The sidecar proxy is what we call a data plane, and then there's a control plane that goes and manages all of the service discovery and policy enforcement. And then all of that runs on top of the Kubernetes platform itself.
Wow, it does a lot. So that's awesome. I always think, like, when I'm talking to people about why they should be cloud native or why they should adopt microservices, and one of the common themes that comes up is people say that it simplifies the code that they write. Like, they get to write smaller services that do very small things. But what they don't realize is that all they're doing is moving that complexity down to the infrastructure layer, down to the network layer. And that's why tools like Kubernetes and Linkerd are just so important when it comes to these new microservice architectures or cloud native architectures. So
you're totally getting me set up for a rant. Microservices, in my opinion, don't actually solve a technology problem. They solve a human problem. The whole purpose of microservices is to go and give teams inside organizations ownership of their own destiny. So it's not about like writing little tiny pieces of code, because you're exactly right. That little tiny piece of code that runs as a single service may be easy, but now you need to think about all the interconnections there. And if you go and write 1,000 microservices, you've got 1,000x the complexity of just shoving it into one place.
Yep, exactly. I love that, the human problem line. I'm going to steal that. I borrow it, of course. I credit you.
Please do. I think more folks need to hear it. And it's a very important problem to solve. It's very powerful. It's the problem, to your point, that all of the cloud native solutions solve is giving teams and developers control over their own destiny. But it's a human problem.
Yeah, definitely. So let's, this stream is all about getting hands-on and showing the technology and how it works. So let me cover there we go. Let me cover where we are. So with this stream, I do very little upfront, but of course we do need a few things in advance for this. We want to focus on the Linkerd aspects and nothing else. So in order for that, I have used Equinix Metal and the cluster API, and I've provisioned us two Linkerd clusters, Linkerd 1 and Linkerd 2. Not very imaginative naming, but hopefully something I won't forget. That's it. That's all I've done. Everything else we're going to do live, and we're going to do it now. Now, I also have the Linkerd homepage here, and I'm assuming, like everyone always does, they tell me, let's go to the docs. So what is step one for getting started with Linkerd on Kubernetes?
Let's go hit that getting started link there, and hopefully it will be self-explanatory.
I knew you were going to say that, but I always ask it. I always ask. All right, so I'm not going to run kube control version. I'm pretty confident with that. In order to
actually, is your cluster 119 or 118?
It's 119.3.
Ooh, I should have asked this before. We'll have you use the edge. The TLDR there is that Kubernetes 119 has some interesting upgrades because of Golang, and certificates don't work quite the way that they should. So if you see that step one install command there, instead of doing run linkerd install, add a -edge to the end of the install, and we'll get you a edge version that will work. For those who are paying attention here, our edges are unstable versions, but as of probably this week, we'll have a new stable version coming out based off of our unstable. So you'll be seeing the latest and greatest here.
Well, we do like to live life on the edge here, literally. So, I need to change this. So you want me to add...
Yep, -edge, just on the URL. Note on the...
Install edge,
yep.
like that.
Yep, that's it.
Okay, so let's see if I can run Linkerd version.
This is a Cobra, so yep.
All right, Edge
cool.
2010.6. So I think we're over the first hurdle. We're now running the Edge one. Okay, so now recommending that I run a Linkerd check pre. So what does this do? What's it looking for?
So we're just going to validate that your cluster is all ready to get Linkerd installed on it. A lot of that's going to be RBAC and making sure that you've not got any crazy settings on your cluster. We feel pretty strongly in our check infrastructure. As I'm sure you've probably noticed, Kubernetes clusters tend to be a little bit of snowflakes. Everyone is different. Even though we say that it's all cattle, it's not. Clusters are pets. And so we like to make sure that folks know that Linkerd can get running on their cluster right away.
So if this comes back and tells us that our cluster is not applicable, we're just packing up and going to the pub, right?
That's yes, I could go for the pub.
Looks like we're getting texts. I'm sorry, mate. We're stuck here. Okay, so status checks are all green. So this is just querying the Kubernetes API, checking the Kubernetes versions, and making sure that RBAC permissions are in place so that it can create everything it needs.
Yep.
And I see net admin and net raw, which I guess makes sense as a service mesh. We've got some networking stuff that has to happen. So.
Yep.
Okay, so then we go through the Linkerd install, and we're just going to apply that straight to Kubernetes, which is going to install, I'm assuming, our Linkerd control plane and data plane?
Just the control plane, though. The control plane uses the data plane.
Okay.
And then that command Linkerd install just outputs YAML. So if you felt like auditing or taking a look at that, you could. And this is kind of meant for kicking the tires and getting started. as you asked before the stream got started, there is a Helm chart that you can use. But like most things Helm, it takes a while to go figure out what settings you want and how to configure it. So we kind of recommend getting started with this and then figuring out where you want to go for a production install.
Yeah, I can see there's obviously quite a lot going on here with this kind of quick start approach. Grafana, there's proxy injectors, Linkerd web. So I'm assuming we've got some sort of dashboard or UI.
Yep.
Lots of stuff for us to poke and play with, which is good. So, all right, let's see. So we now have this command. So this is no longer the pre-check, but it's now going to make sure that what we've just applied works.
Exactly. And we're going to sit and wait while the containers come up. It's pretty frustrating to go and try and run through the get started guide and not have everything ready yet.
It'll be all right. I mean, it's good to see this stuff running. So, I mean, it's not exciting television, but people have to see what happens here. And you know what? I love it when it fails. Don't get me wrong. See when the docs are great and it works and we go through it. Cool. I love intuitive docs. I love it when I don't have to think. But at the same time, when things break, it's also good to be able to dig in and see what's actually happening under the hood. So.
Totally.
But we're out of luck. Even on our Linkerd Edge release here, we're still just getting this little green tick everywhere we go. So, all right, let's keep going. I'm done, right?
Yep, you have a working install.
So if I just run, I won't bother with an ampersand. This is going to do some sort of port forward, I presume. Oh,
yep.
It's opened in the wrong
that is actually literally just a wrapper around kubectl port forward. We actually use that code. So.
Ah, right. Okay. Yeah. It keeps it nice and simple for people with the Linkerd CLI. So I get that.
Yep.
So this is a dashboard. Is this showing me is this like a Kubernetes dashboard? I see that it's showing me cron jobs and daemon sets, deployments. I mean, is this Linkerd specific or what's going on here?
Yeah, so this is Linkerd specific. Because the control plane dog foods the data plane itself, if you go click on that Linkerd Linkerd link there, you'll actually see the full health of what's happening in the control plane right now, including the service topology and all of the deployments. And so you switched over to Linkerd namespace now. You could go click on deployments. We keep it super close to the Kubernetes dashboard so that it's easy to understand what's going on. But it is Linkerd specific functionality. And then while this is super Linkerd specific, we also have Grafana links. If you notice that link right there that you can go to for pre-built dashboards. So if you wanted to put this up on a TV, something like that, you can do that as well.
All right. There's a lot then, right? So this quick start installer has given me Linkerd running on my cluster as a surface mesh.
Yep.
But it's also got Grafana, which we've seen in the install. I'm assuming there's then Prometheus being deployed also. That's how the metrics are getting from Linkerd into the Grafana. And you're deploying all of these pre-canned dashboards.
Yep.
I guess to give me confidence that Linkerd is doing what I expect it to do, right?
Exactly. I believe pretty strongly in letting folks validate what they just got done doing and making sure that it's all healthy. And so that's kind of how we get to this point here.
Okay, I mean, this is pretty sweet. I'm liking this. So I'm assuming that by looking at this, I mean, there's not really anything running in my cluster yet. So
yeah, right.
This is just Linkerd setting idle to a certain degree.
Mm-hmm.
Okay. So if I'm just going to guess that maybe there's demo app, but there is a demo app. So
sure enough.
Now I kind of skipped over a step there. I'm going to assume it's maybe not important. This is just.
That's pretty fun to take a look at. Pull it up and we can chat a little bit about it.
Okay. Can I close the port forward or should I leave that open? All right.
Nah. So we come with a tool. What is this? Top. This is Top. So we come with a tool called Top, and this is watching all of the communications in the cluster live and then showing you the top of what's happening in the cluster. And so you'll see each path, the source and destination. And so this is a fun way to kind of take a look at what's going on inside the cluster. Here you'll see that the Linkerd installed Prometheus is going and scraping a whole bunch of deployments. those IP addresses are actually kubelets going and doing readiness and liveness checks, as you can see by ready and ping. And so as the scrapes and the rest of that happens, you'll see these go up with success rate and all the data. So this is kind of a fun thing to pull up if you are doing a deployment or something like that. You can kind of watch the health of what's going on as the deployment goes out in real time.
Awesome. So let me throw a few questions at you then, because I'm curious, like right now what role Linkerd is playing in this idle state. Like, we're not injecting a sidecar into anything that is pre-existing in my cluster. Is that right?
Correct. Your cluster is working the way it should be, specifically because the service mesh goes and gets part of the data path. And let's be honest, service meshes aren't perfect software. And so stuff is going to break. And we really, really encourage folks to do things incrementally. And so kind of where you're going with this, I think, is just add it to one workload and then slowly roll it out on your cluster. So we try pretty hard not to touch or modify anything until you are ready to opt into it.
Yeah, I think you've read my mind to a certain degree there. What I'm thinking is, not a lot of people are in a position like this where they have this fresh cluster, they're deploying their workloads with the service mesh already pre-existing. So like, I can take a very heavy production-based cluster, add Linkerd to it with probably not too much of an overhead, and then slowly start to roll out those sidecars wherever it maybe makes sense, or wherever the priority for retries and all the other features comes in, and just take my time with it, right?
Yep.
Okay, so let's get this demo app deployed then. So emoji voto, and we're going to curl and apply.
And this is just a gRPC app that's got a couple microservices in it. And we'll be able to walk through how to go and diagnose an issue because we've actually got a bug in the application.
Intentionally or?
Intentionally, yep.
Yeah, okay.
It's pretty fun to go and see how easy it is to track down issues that were something that would take you forever before Linkerd. We had one Linkerd user who rolled out a service and it was an order of magnitude slower and no one could figure out what was going on. And they just ran top, and sure enough, there was the endpoint that was going slow. And so that, got them to the exact piece of code they needed to change within, 5 or 10 minutes.
Awesome. All right. So let's do the port forward and see what we're playing with then. Okay, let's see. 80. So yep. I get to vote on my favorite emoji.
Yep. And the spoiler here is that the bug is the donut emoji. If you try and vote for that, it will give you, I think it's a 404. Yep.
Yeah, okay. But any other emoji, let's do, everybody likes the monkey. There we go. So where's the,
so we've got
votes in here.
So we've got a load generator that is going and voting pretty much randomly so that you can go and see the data that's going through instead of having to generate 1 or 2 requests yourself.
Okay, that makes sense. Okay, so these are just going to arbitrarily go up then as that load generator is applying the fake votes. Okay, so we've identified the bug and the donut, right? Is that the next step? Are you going to show me how we resolve this?
I think so. Let's go back to the docs. It should walk us through what's going on there.
We don't need docs. We'll make
that's right. So we added emoji voto, but we haven't actually added Linkerd to it yet. So what you're using is the unmeshed service. And so the next step here is for us to add Linkerd in. And to do that, we're just going to get the YAML directly from the cluster. Obviously, this is a demo. I wouldn't do this in production or anything like that. And then we're going to run the Linkerd inject. And yeah, why don't you just cut and paste that? Because what this is going to show off is the only thing that inject does by default is add that annotation right there, that Linkerd inject enabled, which is then going to go and hit the proxy injector and have, when the pods are created on the Kubernetes cluster, the proxy and the init container will get added on.
Okay, so it's just that one annotation. It's not
Yep.
doing anything else. Okay.
Yep. And so you can add that yourself if you so felt like it. Inject will do a manual inject as well. If you're in an environment where mutating webhooks don't work for you, you can go and add it directly into the pod spec there. But for most folks, we recommend the injection proxy injector kind of process there.
All right, so we'll just go ahead and apply that then. And cool. So I injected okay, so there's 4 different, yeah, 4 different deployments, and they've each been injected. So if I run get deploys,
emoji Voto namespace.
emoji Voto, and I'm just going to describe a pod and grab the first one. Then we should just see the sidecar should be there. Is that right?
Yep.
Linkerd proxy. Okay. So now this traffic, if I do the, I'm going to assume it's going to tell me to port forward again. Oh no, it's telling me to, oh, we've got a checker. All right, let's do it.
Yep. Even more checks. So you've checked the control plane. Now let's check the data plane and make sure that that is phoning home and everything's working there, which it is now. So that's great.
So these check commands, right, they obviously give me a little bit of confidence in that the changes I'm doing are doing what I'm doing. Do these have other applications and production workloads to check that things are going on, or is it really just for this walkthrough?
That's a really great question. They were kind of originally made for interactive, someone setting the cluster up and working around and doing it. But quite a few folks, I'm sorry. Let me fiddle with this for a second here. Quite a few folks use it in production as health checks as well. And so it can be used for both.
Yeah, that was kind of my vibe as I ran that. It's like it would obviously be quite nice if I mean, these check things obviously have a lot of logic to understand that Linkerd is healthy. So maybe I could continuously run them every half an hour, make sure my cluster is Linkerd happy to a certain point.
We actually have an open issue at the moment to add a JSON endpoint on the control plane to let you kind of automate this whole part of the process, which I'm pretty excited to see land.
Okay, cool. So what is this linkerd stat deploy command?
Run it and let's see what gets output. So that is the golden signals of your deployments. The Google SRE handbook says that a golden signal is kind of the most important thing to pay attention to. If you've got to monitor something, you should monitor the golden signals. And those are success rate, RPS, and latency. In particular, P99 is kind of the latency that you want to measure. P99 means the 99th percentile of latency. So if you take the average, which is P50, what you're going to do is end up missing quite a bit of latency. Your P99 is going to be pretty sensitive. And so users run into that 99th percentile slow kind of latency. You'll know about it immediately. But as you can see here, we've actually got success rate issues because of our donut emoji.
Yeah, I see that the 83% success in voting and the 91 in the web. So this is our error. Now,
and without Linkerd, you would kind of be up to a user giving you a phone call and saying, hey, this isn't working. What's going on? And because it's a user, they probably wouldn't tell you that it was the donut emoji or that the app was broken or, all kinds of stuff. And this gives you a pretty easy, again, way to go look and immediately figure out what's going on there.
Okay, that's nice. So I'm going to throw something out there. I don't know if it's going to come up another part, and I'm just being impatient. But right now I'm thinking the load generator that the quick start is deployed here. Can we ramp that up? Does that come later?
What do you mean?
Like it's generating load, but not a lot. Can we have it?
Oh, sure. I mean, we could scale that deployment up.
All right. Okay. Should we do that now, or will we stick to the script?
We can do it now if you want to take a look at that. I don't see any reason why not.
I'm just curious. So if I all pods.
It's a vote bot. So if you just do a scale replicas on VoteBot to
okay, so K emoji voto. I'll just edit the deployment. I can never remember the scale command. What is it? Scale emoji.
deploy emoji or deploy vote dash bot.
Vote replicas equal
dash replicas. Yeah.
Like I said, I never remember the skill command. I always end up just getting in and modifying the spec. But all right, let's see. Well, have we got one just now?
Yep.
Yeah, we've got one pod, 2 containers. Let's how brave are we feeling? Let's do 10. And then we'll run emoji voto, get pods. Let's see. So if I run our stat command.
So we'll see the RPS go up here, but the stat command is based off of Prometheus. And so there's about a 60-second lag between when you do something and when you actually see it. If you were to do a top here, you would see the rate go up pretty much immediately.
What was that top?
Just do a top deploy. And so you can see here that there's quite a few requests coming in now.
Okay. Well, I can be patient and wait for our stat command to update. So,
but
yeah,
there we go. We've got it up to almost 20 RPS now.
All right. Remind me before we finish to scale that up to like 1,000 or something just for
Nothing good.
Okay, so we ran the top deploy, and then we're going to run a Linkerd tap.
Mm-hmm.
Let's wrong copy.
So tap is like Wireshark for your cluster. So this is the live requests as they're going through the service mesh. And the big use there would be that you can actually get all of the details that you wanted on what's failing pretty quickly. Tap will also do full headers, and so you could go and look into, the actual headers that are going through for these requests. Go do even more debugging.
Ah, okay, cool. So we can actually see every single thing that's happening on the network. Nice. Okay.
Yep.
And it's also available in the dashboard. So
exactly.
Yeah, we could probably pop open the dashboard in Grafana once we've done it.
Yep, that's pretty much it.
So how do we identify the donut problem?
So you could do tap and just grep for a status that's like 404. That might be a 500. Try a 500.
I was wondering, do we also have? No, I was going to say,
there it goes.
Have to wait for a donut vote, but we have 500s coming
Yep.
through. Okay.
Yep. And so that pretty much tells you right there that those requests are failing both on the outside and the inside on the proxy. And you could then look at the logs here, which has the paths, and figure out what's happening there.
All right, nice. So that's our demo application finished.
Yep.
So can we use this demo application to explore some of the other features that Linkerd brings to the table?
We might need to install a different, depends on which way we want to go. So we can go look at, let's go through the smorgasbord, and I'll let you pick your own adventure here. So we could do take a look at tracing, which is kind of interesting. We could go look at retries and timeouts. Maybe the easiest thing to do would be to look at TLS and how that's been automatically set up. I don't think we'll need a new demo app for that. Some other fun stuff to look at would be retries and timeouts, or perhaps the most interesting one of all would be chatting a little bit about Canary rollouts, why they're important, and how Linkerd helps you out there. But those are all kind of good.
Yeah, there's pretty much we could just go through every feature if we had the time. But let's cherry pick then. Why don't we? Because I think we've got, we have access to this Grafana and a dashboard set up, and I'd like us to be able to see how we can use that. So what if we start with something hopefully easy? I'm making some assumptions here. But what if we just do fault injection and start making things break and then see what happens in our dashboard view?
Sure.
Okay. I don't know what happened there. Okay. So I should probably click on the feature. Is that going to take me to the docs?
Yeah, we've got a tutorial for that.
All right. So,
but this is a different demo application that we'll need to install.
That's okay. We can do that. So this is just going to create a Bix app namespace and deploy a Bix app thing. So let's just let that go.
And if you scroll up, actually, you'll be able to see a picture of what the architecture looks like a little bit more. So there's the architecture for this. We've got a traffic generator. It's a web app front end. There's an authors service and a book service. And so we'll be injecting errors into the books app calls themselves. This is kind of an interesting tutorial because it uses a primitive called TrafficSplit, which is also how we do the Canary rollouts. But a TrafficSplit basically allows you to weight traffic. And so the traffic coming out of any service to books will get split. 90% will go directly to books and 10% will get sent to this fault injector that we're going to spin up.
Okay, so we're taking off a few of the features then with this tutorial, which is
Yep.
Good. So we can probably skip the stats, right? Or should we just take a look at them?
So you're going to want to do that command just above. The Books app also comes with a failure in it by default. And so let's patch it and make it so that it's not failing anymore so we can see what the fault injection actually is doing.
Right. Okay. So we're fixing it so that we can break it again, right?
Exactly.
Nice. So what we should see when we run the stat here is this has given us just a little bit of confidence that we're going to get that success rate back up to 100%.
Eventually. Again, stat is on Prometheus, and so it'll take a while for that all to fall off.
Okay. Well, books and web app are going down, but offers went up. So maybe we just need to give that a little bit of time.
Yep.
All right, let's see what we're supposed to do next. So we want to create a faulty backend. So to do this, we're creating an Nginx config that returns 500s and deploying it.
Yep.
Right, got it. So let's get this
copy. It is very complicated. And this is just going to always return a 500 for any request that comes through it.
Yeah, so the Nginx config here, I mean, it's just saying always return a 500. And
right.
Then this deployment of service is just to deploy that Nginx config, right? I mean, there's nothing particularly interesting there.
But you could imagine making this Nginx config so that it returns malformed responses or error codes other than 500, or randomly returns responses. And so the testing is pretty extensive that you could do with this kind of a pattern. It composes really well.
Okay. And this TrafficSplit is a service mesh interface component that allows us to say whenever someone requests the books service, we're going to give 90% of the requests through the working one and 10% through the error injector.
Yep.
I can read YAML. Okay. So that SMI spec just means that it should work on any service mesh. This is not Linkerd specific at this moment in time. Is that right?
As long as your service mesh implements this CRD, yes. And let's see, console, Istio, and Traffic all implement that spec along with Linkerd. Though sometimes it requires components. Like with Istio, you would need to install an extra component. Oh, and the Open Service Mesh from Microsoft also implements TrafficSplit. So.
Okay, so I think we're being too nice here. So let's make things properly feel. So we'll just bump that up. Okay. So that means, let me go back to this instead of guessing all the time. Okay, I'm not, what does this do? I'm not sure I'm understanding that from first sight.
So along with being able to look at the metrics on a per service basis, we also allow you to look at them on a per route basis. So if you tell us what routes you have, we will collect metrics on those. This is just kind of showing off that you can do that. We haven't told the control plane about what those metrics, what those routes are, so we won't see a ton, but this will give us the two. So what this is saying on some level is the web app deployment, when it sends requests to the books service, let's take a look at those metrics.
Okay. So the Linkerd DCLI is pretty much providing a lot of really cool visibility features here into our applications.
This one might be interesting. Why don't we do a stat on deploy web app? But that actually shows it right there. We can see that the books service has got a 50% success rate, and the web app has a 25% success rate. So that actually gives us pretty good details right there.
So why did the roots command not give us anything there?
I would need to go dig into it. We're on the edge, and I'm wondering if there's a unique configuration issue that we need to look into there.
Okay. I wonder if I
Yeah.
just set the error rate too high or if I'm messing with it, but we'll move on. So, yeah, okay. Let me run that stat again. Okay, so yeah, so we can see the 50% give or take error rate then within the book service. Excellent. Okay. I mean, so that was it. That fault injection. This TrafficSplit was our fault injection. So the fault injection can be, that's not necessarily something specifically that Linkerd is providing, like, to mock HTTP response. It's something I can just configure my own use case, my own faults, and then split the traffic across that. So there's quite a lot more flexibility there rather than Linkerd saying, oh, I'm going to respond with a 400 for X percentage. So.
Right. One of the big themes for us as a project is kind of doing composition, giving you the primitives that you need to go build higher level kind of concepts. I can write a Nginx config to do fault injection that does insane things. And it's just a bunch of functionality we don't really ever want to implement in Linkerd because it complicates and adds complexity and makes it harder for everyone to use.
Okay. With regards to this TrafficSplit, then, this is also how you would do the Canary deploy, or is there something on top of that would be provided?
So that's the primitive that we provide. There's a CNCF project called Flagger that is absolutely fantastic that then goes and does the orchestration of the Canary rollout, because a Canary wouldn't just split the traffic 1090. It would split the traffic 1090 and then watch the metrics until they make sure they're successful and then slowly increase the traffic split until it's 100% on the new version.
Okay. And I'm assuming the backends list on this TrafficSplit, right now we're doing 2, but there's no reason there could be more?
Mm-hmm.
Okay. Nice. Okay. I can see a lot of different use cases for that kind of feature then.
Yep, we use TrafficSplit pretty heavily on our multi-cluster stuff as well.
Awesome. Hopefully we have a little bit of time to take a look at that. Okay, so we're got this amazing cloud native application. We've got the ability to do Canary deploys and traffic splitting, traffic shaping, whatever we want to call that. What about the retries and the timeouts then?
So we've got a tutorial for that. There should be a link at the top there if we want to go and configure the retries.
There we go. So this is, see if I can work this out.
So if you see the link there right above retries, check out the retries section of the books demo. So we've already got the books app running there. If you scroll up, what we're going to need to do is add the service profile. So scroll down a little bit. Keep on going. It's a section titled service profile. Oh, wait. Sorry. Nope. Scroll up. It's the literally that section right there. Okay. So there we go. So the service profiles are, I kind of hinted that you need to tell us what routes you have. And the reason for that is that cardinality is the cluster killer. The more cardinality you have, the bigger your Prometheus gets. The bigger your Prometheus gets, the slower your cluster gets. And so we need you to tell us what routes you've got. We can consume Swagger or Open API specifications and gRPC protobufs. We've also got a couple other commands to go and help you build out those service profiles. But why don't we grab the Swagger profile here for the Books app and generate a service profile for that and then apply it to the cluster.
Okay, I'm just going to take a look at what this outputs. Okay, so a service profile. Okay, it's just a list of the routes then.
Yep, that are regex.
Yeah,
that's about it.
I always expect to like be revealed by some massive complexity thing, and then you're like, oh, it's just YAML, always YAML. Okay, so
it's YAML all the way down.
Yeah, it really is. In fact, the service profile was right there in the docs, and I just wasn't looking at it. Okay, perfect. So now that we have a service profile, do I need to run this as well?
Yeah, let's add profiles for the other two services, the authors service and the book service.
And then we can verify that with the tap command. So what do we have here?
That's showing us the route. So if you see the path there.
Yes, there we go. All right, path. Is that right?
Mm-hmm. Okay. Is there an RT_route in there somewhere? I'm not seeing it. We might be running into some bleeding edge issues. Oh, no, it's there. I see it.
Oh, there.
Yep.
Okay, cool.
So that's the name of each of the routes in the service profile shows up there. And so if you wanted to put a fancy name in instead of just post books ID edit, you could do that.
Okay, so we've told Linkerd that each of our services has a Swagger file. We've created a service profile based on that Swagger file. Now, how do I tell it to do retries?
Straight to the retries. So if you see, we've got a edit command down a couple steps there. So if we run that edit there.
Okay, and then we're going to make an edit to the root. So we have to. Okay, so let me see if I understand this correctly then. So when we enable the sidecar injection on our pods, we have to still apply service profiles and have retriable. So it's not something that the sidecar just does by default if it sees some sort of HTTP error in the thing. Like we have to be very explicit about the way that we want that to function.
Exactly. And that is because not all routes you want to retry. Imagine having a credit card charge getting retried 1,000 times. That would be pretty bad. There's also retries with great power comes great responsibility. Retries really are a great tool, but it's something you need to be very conscious about turning on. And so that's kind of where we are here. You really can only do them for idempotent requests, so anything that's not got a body, get, head, that kind of thing. And you really only want to do it when you're 100% confident that that's the thing that you want to do. So That's why we have you attach it on a per route basis. And now, obviously, because these service profiles are regexes, you could write a .star regex for your service profile and then retry everything. I wouldn't recommend that, but it's something that you could do.
Would it be possible to, well, I'm assuming with a regex it would be, right? I could just match an all get requests and assume that a get request is not going to have any sort of mutation on the server side, and that's probably okay to be
Exactly.
automatically retried. Okay.
Again, I would strongly not recommend that, but it's doable.
Okay, so let's, it keeps opening in my other window, so let's just, all right, and we want to just add this is retriable here. So
specifically to that author's line.
yeah, which author's head request. Okay, this one here.
Yep.
Done.
Yep.
That's it. That was painless. So let's see what this tells us now.
So this might be our issue with the edge. I don't understand why we're not getting stats here, but if you go back and take a look at the docs, we'll see what the output is supposed to look like at least. And so here we're showing you the effective success and the actual success, which is pretty cool. This is the difference. The retries gets your effective success up from the actual because we're retrying, but it has the downside of increasing latency.
Now, is this edge bug that we're running into something that's only, do we think that's likely only to be affecting this command? Like if I port forward to the dashboard or to Kibana, would we be able to get a more visual look at that?
This would be the right command to see this data. So, and it's all getting pulled from Prometheus. So I don't think we'll have a more visual way to take a look at that.
All right. Okay. No worries. So, okay. I think we understand retries there. I'm going to assume timeouts are pretty much in the exact same vein. We find the path that we want to apply our rule to, yeah, and we add on the timeout. So no point. We won't run through that. Let's see what else we can quickly do then. So is there anything that you're particularly drawn to that you'd like to move on to next?
That's a good question. Why don't, just for fun, why don't we go and do the, it is, let me make sure I can find the docs here. Let's go to the securing your service doc.
All right, let's go.
It's under it's under tasks. So if you click the task link there, down towards the bottom, there is a securing your service.
Okay, so,
and so
sorry, you go.
Oh yeah, so we do mTLS by default out of the box with Linkerd. We actually make it really hard for you to turn off. Encryption is great, but it's a little hard to validate. And so this doc will kind of walk us through using not just, or pretty much all the Linkerd tools and a couple lower level ones to go and validate that mTLS is really working between all of the nodes.
So mTLS is already running on the pods that I've enabled the sidecar on?
Yeah.
Ah, okay.
mTLS, like I said, is enabled out of the box. In fact, tap, the command we've been talking about, that Wireshark for your cluster, requires mTLS because we need the identity to validate that some rando isn't making calls on your cluster to get all of the traffic going through it.
Okay, so that just means that all of the requests that leave my pods are being encrypted for me, and I've not had to do anything.
Exactly.
I mean, I'm sold already on that feature. I thought we were going to have to go enable something, but the fact that that's just now, because I just installed Linkerd and injected the sidecar, that's pretty awesome. So you said it's hard for us to confirm that that works, but not impossible, right? I mean, how do I know that? Do I just trust it?
Well, that was my point. Let's go and take the steps. I don't trust it.
All right, let's see what this command is going to return. All right, so that's okay, all of those are secured. We have our favorite little green tick here. So yes, I see that output. Awesome. And we can run the tap again. And it's suggesting. Is there anything in the tap that would suggest it's encrypted, or is that...
Yeah, so you see the TLS equals there? So there's TLS not provided by remote. That's not encrypted. But if there's TLS equals true, then it is encrypted.
Ah.
And so you'll see some commands there that aren't encrypted. Those are ones we can't. If it's coming from the kubelet, that's not injected with the Linkerd proxy. We don't control both sides of the connection. But anything that's a request between two services, we definitely can. And that's where you see the TLS true.
Okay, that makes sense. So we can validate mTLS with T-Shark.
And this is the don't just take our word for it with all of the tools that Linkerd has put together. This actually adds a debugging container to your sidecar that adds, or it adds a debugging container to your pod that you can then go and run debugging tools on. We use it a lot to go and debug the service mesh itself, but this is a great way to see the raw bytes as they go through and make sure that they are actually encrypted.
Awesome. Okay, let's just reapply that. So it's okay. So it's injected that. Okay, so it's updated the sidecar with the debug option then on each of those deployments.
Specifically, it's added an annotation that will go and add another pod or another container to the pod, which is that debug container.
All right, let's find a deployment. Yeah, okay. So just enable debug sidecar true. Good, because that means it's quite easy for me to add that then without the actual Linkerd inject aspect.
Exactly.
So then we can get a remote shell by jumping inside of that debug container and our emoji photo voting service.
Mm-hmm.
And T-Shark.
And T-Shark is just a command line Wireshark, and we're going to be looking at the port 8080 and taking a look at SSL and then looking at what's going on localhost.
Anything not localhost, right?
Right.
Okay. So it's looking specifically for requests which are leaving the service to another service, which is where the mTLS boundaries are.
So this is actually coming in, but it's coming in on the proxy, e.g. The exterior IP address, not the interior IP address, because the way that service meshes work is that we have some IP tables games that go and redirect all of the incoming traffic into the proxy that then forwards it to the local host. And so if we were to look at local hosts, we would actually see everything in clear text. But as you can see here, we've got nothing but TLS data going through, except for that ready, which is, again, the kubelet calling in and validating that our service is up.
Yeah, the Senac packets, right? These
ones.
Yeah, okay. Okay, that's pretty sweet. I like that. Nice. And that's it. So we've covered retries, timeouts was in vain, mTLS. I mean, and that was safe to say that was all pretty trivial. That did not really require too much effort on my part, which is good. Otherwise, it would all have went wrong. So I'm really happy with that. That's great. Now, shall we? On the home page, we have this big deal about the multi-cluster Kubernetes thing. Now, is that something we're going to be able to look at with the 119, or do you think we may run into some issues with that?
We can definitely give it a try. We changed the way that multi-cluster works, so we're actually going to need to go and take a look at the pull requests on the docs website if we want to get that one up and running. But we can definitely give it a try and see what happens there.
Sure, why not? Let's see what happens.
So if you go to, let me find those docs too.
So I'm assuming I'll need to go through the standard install linkerd command on my other cluster, right?
Oh, so actually, what you're going to want to do is uninstall Linkerd from your current cluster and then do a reinstall. And the reason for that is that to get multi-cluster up and running, we need to have a common trust anchor. And the reason for that is that the trust anchor is how we do authentication, so that randos can't be requesting services inside your cluster. And so actually what you're going to want to do is
just change this.
I'm going to send you a link because it's probably going to be easiest that way. Give me just a second here.
Yeah, of course.
That is going to be the docs for that.
Okay, so should I first do the Linkerd install but delete path to get rid of it from this?
So I would do an uninstall.
Oh, that's easy.
Uninstall and then pipe that into kubectl delete. And since we've got those two other namespaces, you probably want to clean up the emoji voto and booksat namespaces. The reason why we need to do an uninstall here is that we install a couple API services, which are Kubernetes resources. And if you delete a namespace and have an API service running, Kubernetes loses its little mind. And so you definitely want to do that, but you can just delete the namespaces for booksap and emoji voto.
I was thinking about completing it. Maybe I should just have taped it. Yeah, okay. Okay, deleted. So let's pull up these docs. Well, eventually deleted. I have confidence. So we're going way off script then.
Way off script. Oh, in fact, so way off script that the command that I thought was in there to cut and paste stuff is not there. Let me give you that command real quick.
So is that a command I have to run before the multi-cluster install, or can I go ahead and get this started?
Well, so the multi-cluster install is only going to install the multi-cluster components. What you're going to want to do is click on if you scroll up on that doc a little bit, you'll see that you require 2 clusters and a control plane installation that shares a common trust anchor. So click on the trust anchor link there. And we're going to create a trust anchor certificate. I would recommend doing a brew install step here. But if you are a crazy OpenSSL Kung Fu artist, I won't stop you.
No.
Brew install step -CLI.
I can always quickly look that up. It's just step, I think.
Cool.
And I'm assuming step is just some sort of utility for generating X509 certificates or something similar. Yeah, okay.
It's actually a great CLI that does a lot more than that, but we use it just for generating the certificates.
Okay.
So that created a trust anchor, and then you're going to want to go and do the step certificate and create a issuer certificate. So there is a trust anchor that goes and installs, that kind of is a CA and maintains the trust across your 2 clusters. And then theoretically, though we don't need to do it here, you would have an issuer cert that you rotate on a regular basis. That's actually what the proxies get their certificates from.
Okay, this is making sense to me now. The fact that we're going to do multi-cluster means we need a CA that is trusted on both for the communication to be effectively encrypted across that boundary. Do I have to use something here? Could this hook into tools like Vault to provide that top-level CA?
Well, so this is an unfortunate co-location of terms. There is a type of certificate that is a CA certificate, and then there is a type of service that is an online CA. So you can use Vault to go and get the certificates if you wanted to, but this is just a way to add them yourself. While the trust anchor needs to be generated, we also allow you to do automatic cert rotation with Cert Manager if you so wanted to do that.
That's sweet. Okay. So is my next step just to keep following through with this?
Yep.
All right.
And so that'll install it on one cluster. And so you'll want to then just select the context that you want for the other cluster.
All the things.
All the things all over again.
All right. So kubeconfig equals linkerd2.json. Let's see if that works. We'll see if we get created or configured. All right, let's just do this. And then reapply that command. Okay. So we have Linkerd configured with our trust anchor deployed to cluster 1 and cluster 2. I'm assuming we can skip this Helm and jump over.
That was just an alternative for Helm. Actually, just go back and we should be able to continue the docs as they are laid out.
Okay, so now we're doing the multi-cluster install to each cluster.
Mm-hmm.
All right, so let's just do cluster 2 first. I should just split this, shouldn't I? That'll be a bit easier. So Linkerd2, Linkerd1, and then do Linkerd1. All right, so we have a check command. I love these check commands. And we got all the green ticks. Good. So we've not linked the clusters yet. So see if I can work this out. So what's the context and this context?
So you probably won't need to worry about the context here. This is kind of from a blog post that we've got that talks about two different clusters, the East cluster and the West cluster, and kind of walks you through things. You'll want to delete the context from this one, but the idea here is that you're going to run the Linkerd CLI on your Linkerd1 cluster. That's going to, the multi-cluster link is going from the, excuse me, let me come at this from a different angle. When you run Linkerd multi-cluster link on Linkerd cluster 1, it's going to output all of the required configuration for Linkerd cluster 2 to talk to Linkerd cluster 1. And so what you're going to want to do is run the Linkerd multi-cluster link on cluster 1, get the YAML, and then apply that YAML to cluster 2.
Got it. Okay, so I can modify this in line. So let me pull this along. So instead of context east here, which is just a Kubernetes config, I can leave that blank, which is using cluster 1, and we give this a name. So can I just call this Linkerd1?
Yep.
And then here, we're actually just going to point it to the other kube config, I guess.
Yep.
Linkerd2.json. And that's going to link cluster 1 to cluster 2.
Right.
What did I get wrong?
It says no objects passed to apply. There might have been an error there.
Okay.
What's the...
No ingress.
So the problem there is that we need to have a load balancer with an IP address, public IP address, so these two clusters can talk to each other. So this is saying that we don't have a gateway address there yet. So why don't we run kubectl on the Linkerd-multicluster namespace and look at the services, figure out what's going on there. Dash multicluster. So we're still waiting for you to get a external IP address.
Which will never work.
Uh-oh.
Yeah, so this is a bare metal cluster that needs a very special type of load balancer, either kubevip or mTLS. Let me quickly grab that and see if I can get that working in under a minute. And if not, we will abort.
Cool.
Okay, so let's see.
So while you're doing that, let me kind of explain what's going on here. We've actually got a blog post that talks a lot about it. In our experience, when you start talking about multiple clusters of Kubernetes, it is very unlikely that they can route to each other. Imagine having a cluster in two different cloud providers, for example. Having a flat routable network is basically impossible. And I mean, you can do it. It just requires a whole bunch of effort. And so what we do is rely on services with load balancer IPs that are public and routable. And then we can just pass traffic through those gateways into your cluster. And so you don't need to think about any low-level networking here. It just gets an external IP address in most cloud providers, and you're good to go.
So I did install kubevip, but to be honest, I'm not sure if I'm going to need to be able to set that up with anything. So let's see if I can see anything immediately in the logs, and if not. So I did elect the leader. And we should have a CCM. Cloud controller running. I think we might. Oh, we'll give it 30 seconds. We may get
Cool.
an IP address. In fact, I could probably take a look here and see if we have anything. Yeah, potentially. So normally there would be one elastic. Oh no, because I have two clusters. Okay, we're maybe not going to get one then. Drats.
Oh, bummer.
Foiled. Oh well. It doesn't matter. Like, that would have been cool to show off, but I didn't think about the ingress aspect of it. So next time I'll definitely get that working.
Cool. Yeah, I'm sorry. I didn't even think about giving you a heads up on that one.
Well, I guess you wouldn't have to, right? Normally it's not a problem. Cloud providers have this little add-on that works with the load balancer service type. Unfortunately, bare metal just is a little bit different and does require a little bit of upfront work. I could have installed mTLS, kubevip. I think with kubevip, actually, I need to tell it the elastic IP that it has control of so that it can pass that around. And I just don't have that config. And I keep randomly hitting it going, maybe it'll just magically come into fruition. But it's not going to happen. Anyway, and I think that's great. Is there anything else quickly you want to go over before we wrap up that you think would be cool to show off?
No, I think that's pretty good.
All
We've
right.
kind of covered most of the feature set, to be honest.
Yeah, I mean, there was a lot going on there. And again, it was really trivial, really easy to play with. I just like how intuitive the CLI was itself and how easy it was to work through the documentation. Like, it was just, well, it was a pleasure to work with, actually. So
Good. Thank you.
Well, I want to just say thank you very much for joining me, taking the time out of your day to come and show us Linkerd. I'm looking forward to exploring and playing with it more. It's a really cool tool and service mesh. Like we touched a little bit on this. Just why would I want this thing in my cluster? With the complexities that we're pushing down from the software layer, and I think Linkerd plays a big part of that. So thank you for joining me. Have a great day, and I will hopefully speak to you again soon.
Awesome.